And a good afternoon. This is Studio Offshore Energy from TKI Offshore Energy. My name is Bob Meijer. I'll be your host for this webinar. And this is a special edition, I would say, of our Studio Offshore Energy. Many times we discuss reports and research projects, but this is about a new innovation call that we are launching today. It's a special call around the TNO Switch Lab facilities, and you'll hear more about that during this presentation. And the presentation and the webinar will be recorded, so it can also be looked back afterwards. And if you have questions, please launch them in the chat function. There will be a short introduction by myself, and then Iracha and Glenn from TNO will present the ins and outs of the Switch Lab facility and what you can do there. And after that, we'll explain how to apply for innovation subsidies to work at the Switch Field Lab. So starting off with basically the background of why we do this. And we all know that we've got a very big wind energy ambition in the Netherlands. This is for offshore, but also for onshore wind. The policy is clear, but there may also be potential further increase in these ambitions. So this is the outlook. Now, this outlook poses us for a number of important challenges. We're using a lot of materials, and of course we must make these projects very circular. Safety is of course an important item, but also the use of space, whether this is onshore or offshore. We're always constrained in terms of the use of space and also the ecological space. But a very important element in the scaling up of wind energy is to integrate these vast amount of power into the energy system, basically to get them to the point where we can actually use them. Now, to make that effective, what we see is there's a kind of a change. We see more and more hybrid energy projects where wind energy is combined with storage, short-term or medium-term storage, but also hybrid generation. For onshore projects, this is getting more and more common to combine wind energy projects with batteries, with solar energy. But also for offshore, there are outlooks towards having solar generation also in offshore wind farms, but also the combination with storage, energy storage, or conversion to hydrogen, for example. Also, local use is one of these ways how we can make these hybrid projects to have, for example, data centers or industrial energy use very close to the place of generation, whether this is on land or whether this is offshore. Now, what's important there, and that's what we also hear from many developers of technology, that there's a requirement to develop this, but also to test this. We need proof point facilities to be able to guide our research by learning by doing, but also to demonstrate the capabilities of new technology to take it to the next level. And field labs and demonstration sites are very material in this. So in the Netherlands, there are many field labs and demonstration capabilities available. And one of these is the field lab, the Switch Field Lab of TNO. So around this Switch Field Lab, we've organized a challenge where you can that you can enter with your project idea, with your product ID maybe, that you want to develop or demonstrate at such a facility. Now, there's a subsidy available for your project. Here you can potentially win €250,000 in innovation subsidies. So that's a very serious amount that you can use for basically the research activities, but also to fund the use of the field lab itself. Now, so we launched this call for project proposals or project ideas, I must say, in the initial phase, and we'll come back to the procedure, how you can actually apply for this in the end of the webinar. But what's important is that your project idea is around the integration of large-scale wind energy, whether this is onshore wind or offshore wind. It is around large-scale wind energy in combination with other elements to integrate this into the energy system. And this can be storage, it can be solar, it can be battery systems. And the good thing is, at the Switch Field Lab, these facilities are available. Your innovation could include software, hardware, and basically it could be about very many subjects, including digitization, cybersecurity, but also, as I mentioned, for example, the production of hydrogen. And of course, combinations with solar energy are also possible there. For this subsidy, the PPP or PPS-toeslag, PPS innovation subsidy rules apply. And you can find those on our website and also on the RVO website. And the idea is you can file your project ID. These will be evaluated by an external committee. And eventually there will be a winner selected that can receive access to the Switch Lab facility, support by TNO for the development and demonstration activities. So you will be working with TNO on this. And of course, the financial support for your project. So basically to go in short, so we're launching a subsidy call for project ideas around the integration of large-scale wind energy production at the Switch Field Lab facility. Now, I would like to hand over to the TNO team that's available in this webinar to explain more about what the Switch Field Lab is and what you can actually do there. So I'd like to hand over, I think it's Irache, you're going to give the presentation. Then I'd like to hand over to you, and I'll stop sharing my screen and you can take over.
Thank you very much, Bob. Good afternoon, everybody. I am going to share my screen now. Can you see it, Bob?
I can see it, definitely.
Yeah. Good. So we at TNO are going to downscale on what is necessary on the Switch Lab, and I will explain what is the Switch Field Laboratory first. What are the components there, what it consists of, what are the relevant themes to the call, and then at the end I will as well present a few examples of some of the projects that we are running in the laboratory, kind of an inspiration for your ideas. Well, the first thing is that the Switch Field Laboratory is an open research and development facility jointly operated by TNO and Wageningen University and Research. It is located in Acres site in Lelystad, and it provides a unique environment to develop, test and validate, and of course the risk innovations in renewable energy-based hybrid systems. The laboratory, it is a scaled hybrid power plant which integrates several systems for power generation, for storage and for conversion. Here in the picture, you see on the left side the area that consists on the Switch Lab on 6 wind turbines of its 10 kilowatt each. As well, there are PV systems, battery systems. We have electrolyzer-based PEM stack, a transformer, and we have as well several containers, which includes ICT utilities, SCADA, energy management systems and dashboards, and the digital shadow system that I will explain in a minute. So together, these assets can be operated as a single hybrid power plant and enabling full system coordination, flexibility testing, and market-oriented control strategies. In order to have more information about what are in the Switch Lab and more documentation on the assets and the specifications and requirements, there is a link here on the bottom, keeping the electricity grid stable. It is a link towards the TNO webpage where you can find a flyer of the Switch Laboratory, and you can download to understand a bit of more in detail what are the assets and the specifications on the Switch Laboratory. I will comment later on that you can also contact us if you have any more questions. But first, let me explain what is the digital infrastructure on the Switch laboratory. So this layer, the digital layer, includes an energy management system for real-time dispatch. This energy management system is built upon a planning and scheduling layer consisting of different multi-objective optimization based on weather prediction and market data. We have as well a control layer to execute, which consists on different functions such as a unit commitment, curtailment or peak saving, and based on the schedule from the advisory layer for the planning and scheduling layer that I mentioned before. And then at the end, we have another third layer that it is a base safety layer that it is for protection where we ensure operational limits are not exceeded. Apart from the energy management system, we do have as well a digital twin which emulates the assets, for example, for rapid prototyping. We have as well the SCADA measurement system with the logging data at high resolution. And we have as well Grafana dashboards for real time and also for the historical performance. So at the end, we have the virtual representation of the Switch laboratory, which is available in the digital environment. And we can use this kind of digital environment to accelerate the retesting and the risking of new technologies. And it is possible as well in the digital twin to mimic and simulate a technology that it is not yet installed as a physical asset in the Switch laboratory, but we can mimic through the digital twin, and we can emulate the connection with existing assets in the laboratory. Okay, so what are the main themes for this innovation call that could fit into this type of project? So the first one is the integration of large-scale wind and solar with electrified off-takers. So, for example, projects exploring how large volumes of wind and solar can reliably power industrial loads or higher demand users. We can validate hybrid operational strategies, combining the generation, the storage, the conversion, and we can even improve the market participation, both in the day ahead, but also on the balancing markets to reduce curtailment and stabilize the operations. Flexibility and storage, we can look at short, medium, and long duration energy storage. And as I said before, although even we have one battery installed as a physical asset in the laboratory, we can as well mimic and simulate other type of technologies with the digital twin. In this topic, we are looking for concepts that strengthen the system flexibility across all time scales. Fast response batteries, mid-duration, hydrogen production, even thermal on hybrid solutions. Because the focus is on stabilize the renewable heavy system and to mitigate the variability. And of course, prove the cost-effective flexibility services. Another example of a topic, it can be the multi-commodity coupling with different energy carriers, high molecules, heat and power. And with this, I refer to the innovations that combine electricity, hydrogen and heat, or with other vectors to optimize the integrated energy flows. I would like to emphasize that the projects should enhance the energy management system robustness under variable resources, so all the market uncertainties and also the operational disturbances, ensuring the secure and the coordinated control of the hybrid systems. And finally, but an important one as well, is the digitalization for coordination, interoperability, and multi-voltage digital twins, and of course the cybersecurity part. So here we are looking at digital solutions to improve the communication and control across different assets. What are the interoperability protocols, controllers in the loop, digital twins and emulators to accelerate the design and validate algorithms, and of course, what are the algorithms necessary to have a secure system, looking at the energy resilience. Now I'm going to pass through different examples of projects that we have running at this moment at the Switch Laboratory. And those are just simple examples for inspiration and to show you that we can handle very wide type of topics by using the Switch Laboratory. For example, one of the projects, it is the Magpie project. And the main goal of this project is the smart green ports as integrated, efficient multimodal hubs. So what we are doing here, it is a European project, and in Port of Rotterdam, there is a pilot where there is a shore power hub, where they want to electrify the vessels for a greener operations. And the main goal of the project is to limit the vessel peak demand to reduce the grid tariffs and enable the operating with 2 cranes while connected to the shore power. We have a small demonstration at the Switch Laboratory to support this project, and we are doing a mock-up testing. And what we are doing in the Switch Laboratory, it is to connect wind turbines with the battery to assess the peak shaving strategies on achievable peak demand reduction, the battery utilization, and utilization of local renewable generation, so that with this small scale testing at kilowatt, we can transfer the learnings to the Port of Rotterdam when they want to invest on this shore power hub to electrify the vessels. Another example in which the Switch Lab is as well employed is the Ooster project. This project relates to offshore electricity storage connected with offshore wind farms. The main goal of the project is to de-risk, mature, and validate offshore storage technologies coupled with offshore wind turbines. As you can see in the right picture, we are assessing in this project 4 different storage technologies, looking at different duration levels, like, for example, lithium-ion battery inside the monopile, subsea, different type, a couple of technologies of compressor air storage, a pump hydro at subsea, and also a flexible electrolyzer on a platform. Those kind of technologies are covering different storage durations from minutes to several days. And at the Switch Lab, what we are doing is to mimic the variable loads of each storage asset that could be coupled in the hybrid system to the grids through a digital twin in the loop. So in this case, we are going to use the digital environment, the digital infrastructure to develop a digital twin in the loop, simulating all different technologies connected with a wind turbine. Another example, it is about cybersecurity. The name of the project was Switch to CREP, and the goal, it is the cyber resilient energy farms. We wanted to familiarize with the renewable energy sector with cybersecurity considerations, and we mimic an attack dataset for cybersecurity monitoring and detection. And we aim to explore how the data may be used to detect ongoing cyber attacks. So in the Switch Lab, we demonstrated a rule-based detection of attacks and data manipulation to see what are the holes in the system. And as well, we did the anomaly detection to detect the data abnormality. This was another example. The final example that I am showing today, it is about the Sense Hub project. This project consists of the integration of various energy system modules and technologies in the North Sea. This is focused on offshore wind in this case, but of course it could be extrapolated to the onshore environment. And we look here at how to de-risk the offshore solar technology connected with offshore hydrogen, with a wind turbine, and connected to a grid. In the Switch Lab, what we are doing is an experimental validation where the solar panels, wind turbines, and also the battery is connected together to produce green hydrogen. So we are doing the characterization of the combined wind and solar generation profiles, and we are looking at how to optimize the production from renewable energy to green hydrogen. So after explaining a few examples of the projects that are running at the Switch laboratory, we wanted to explain a bit which type of projects could be feasible at the Switch laboratory, mainly because of the technical constraints of the Switch laboratory. So we are looking for the compatibility with the Switch physical assets. So it needs to be aligned with the capacity, with the voltage that we have there, the size of the assets, and of course the footprint. And of course, it needs to be compatible with the Switch digital systems. So if you want to use the Switch laboratory, we need to discuss as well what type of energy management system you want to use, the SCADA systems, the data formats that should be compatible, or at least we need to find a way to work within the systems that we have at the laboratory. We would also like to understand, if you are interested in working on the Switch lab, all the safety, permitting, and operational constraints that you are looking for. And of course, keep in mind the capability to be executed the project within the available infrastructure and the time frame. So Bob, he will explain a bit more, but indeed, if you are looking for installation of a new asset, and we need to look at the permitting as well, the timelines of the permit process takes a bit of time. So this also needs to be into consideration for the ideation of the project, the execution of the test, and as well the commissioning. And that was all the explanation from my side. The last thing that I want as well to mention is that in the link that we also can share later, there is a flyer, a fact sheet with explanation on the Switch laboratory assets, a bit more detailed explanation. And yeah, the contact points in case you want to discuss the idea, but I think Bob will take over and explain more the procedure of the call.
Yeah, absolutely. And thank you, Irache, for the explanation about the facility. It's really fascinating to see what's all available there. And I think it's also a great opportunity to test these ideas around energy hubs and the integration of solar and wind in the energy system, but also the capabilities to see the effects on the electricity markets and pricing. So that's really important elements in this. There was already a lot of information sent in this webinar. So we explained a bit about the context of why we're doing this. There's an explanation out about the Switch Lab facility itself. It is all about integration of wind power in the energy system. And of course, now is the question on how to apply. And as Irache already mentioned, all this information can be also looked up on our website. We'll share the link to the website later on in the chat, so you can look back at this, and this gives also the pointers to where you can ask questions, but more important also how you can effectively apply for this. So I'm going to share my screen again. And so this is about the procedure that we want to follow for the applications. And so it all starts with a registration. And so this challenge is open for companies, research institutes, universities working together. But it must at least consist of one company, and it can be a small, or medium-sized, or large company. And TNO as a research institute and the facilitator, of course, of the Switch Lab facility. But it could also include more participants. The first step that you need to take is to contact us and request the project ID form. And so that will be available. So the contact details will be available on the website, but you can also read them on the right-hand lower part of this slide. So you can address us to request the template of the project ID form. And what we expect is that you give us a short description, maximum 3 A4, size of the project, of the innovation project, but also the budget that you want to allocate for this, how the project contributes to the objectives of our R&D program and the other criteria that we already discussed about the systems integration aspects. Your cooperation partners, so I already said TNO is always a partner, but there can be other companies that want to join you or other institutes. And the requirements that you may have for the switch field lab. And so also you've seen quite a variation in types of project that Irachi just shown. And some are, say, basically simulations, others have real technology installed at the site. So the requirements that you have for the switch field lab are, of course, important to include there. Now, you may also have questions about whether this would fit or not, because this is, of course, one of the key criteria that it actually fits in the field lab facility. You can also contact TNO about this to interact and to see if you have any specific questions about the feasibility of this. Now, once the project ID forms are submitted, there will be an evaluation and ranking, and then the winner is selected. Then we still need a full project proposal, and after the final approvals of the external advisory committee of the TKI, the project can be awarded and the subsidy can be granted. As already said, the PPS innovatieregeling, the PPP innovation instrument rules apply. You can find those also on our website, so you can see what percentages for subsidy you can receive for specific activities. That's all predefined. So basically summing this up, so the first step is to register, contact us. There is this email address. We'll inform you with the project ID form to be filled out. There's a deadline for that. That's the 1st of May. You need to submit your project ID latest 1st of May. And from there on, we'll do the selection process, and that will take probably a month. And then there's still this last stage of the final full project proposal and the subsidy grant in July. Now, the projects must finish latest in the year 2028. So these are the most important steps that we need to take. So it's registration with us, filing your project ID, possibly also interacting with TNO before you actually do that, or if you would have questions for us, you can also raise them. The deadline is the 1st of May. After that, there will be a month of evaluation, and then the full project proposal can be written and filed for the final award of the subsidy. So what I'd like to do now is to also look at the questions that you may have about this call, or maybe about the field lab. I know there is already one question in the chat, which is about floating wind. Yeah, in a way, this is not so much about the foundation technology, if you wish, whether this is bottom fixed or floating. This is really about, say, wind power that's being generated and the specific characteristics and complexities of integrating the variable wind power into the energy system. And maybe with storage, maybe with conversion or anything else. So this is not about foundation technology. It is not about, say, wind turbines. Yeah, of course, unless there are specific features in the turbine that would facilitate and require a switch field lab kind of demonstration to test these integration facilities. So my answer would be that this is not the subject for this call. Say whether this is floating or bottom fixed foundation technology. So I see also that my colleague Arjan has already posted the link to the call information on our website. So please take note of that. And I'm opening up the floor for any other questions. You would have to put these questions in the chat, by the way. Otherwise, we cannot answer them. I see a few people are typing, so let's wait a bit on that. Okay, how can onshore switch lab validation be made representative of real offshore operating conditions? Yeah, so can I pass that question to Irache or Glenn or?
Yeah, no problem. Yeah, Bob. Well, we are using, of course, wind turbine that are at a small scale, but in the digital environment, we can also use offshore wind profiles. So as I said before, we can mimic offshore wind environment with real information that we can come into the digital infrastructure.
Okay, so you can actually simulate onshore, offshore conditions. And it also holds for probably for irradiation as well. So
everything,
also
and
the solar.
And as I mentioned before, even we don't have a technology physically installed in the switch lab, we can also mimic in the digital twin. We have a battery that it is a battery, a short-term battery, but in the digital environment, we have the representation of different type of storage technologies, and we can adapt to the specific technology of the participant.
Yeah, so that's very versatile.
Yeah.
Thank you, Irache, for answering this. I hope the answer is sufficient for Moradi, who raised the question. And I see a question from Jan about basically you're looking for say a project to participate in with your EMS. And I think EMS is definitely a subject that you can actually also test in the switch field lab.
Yeah, and also I want to add, Bob, that if you are interested in contributing with your idea and you have a novel EMS, we can also discuss to bring as well, together with TNO, another party that we could build in the consortia together. So indeed, if you want to join a consortium, I think it is nice to have contact with us, and we can see what is the best setup for the parties to get involved.
Yeah. Yeah, then I would suggest also to go to the website, follow the link, download the flyer, and contact us for the project ID form. That also includes further information on how to contact TNO with your specific request. So that's what I would suggest. And thanks for offering also the support from TNO to complete a consortium which is not complete yet. I see another question coming in from Martin. Yeah, in the meantime, maybe Irache, you explained a couple of these examples, which can be very inspirational for anybody thinking about applying for this subsidy. So is that something that we can share as well? Can we share the slides that you've presented?
Yeah, of course, we can share the slide that we just presented now. I also have the link to the TNO webpage where we have all the projects. In the flyer as well, there are some links with several projects that we are working on. And as I said, it is kind of an inspiration. If you have a new idea that it may fit into the topics that I explained, we are very welcome to discuss further or even brainstorm with you.
That's great. That would be, I think, a great opportunity. I see there is a question about, is there a pipeline available on the test site for hydrogen transport? Something to test leakages on. Interesting topic. What's your view? Is there something available or something installable maybe? Or?
Yeah, there is no pipeline available for the transport hydrogen, but I would definitely say that we can discuss how to mimic this situation. If you are interested on the hydrogen transport, please, Martin, reach out, send the registration form, and we can discuss how we could mimic this situation.
Yeah, and mimicking, of course, is one thing, but you have electrolyzers on the site. Is it possible to connect a pipeline and maybe a compressor?
That's what we should discuss. At this moment, we have the electrolyzer. At this moment in time, of course, we have plans for compressor and storage of hydrogen. At this moment in time, we do not have an available pipeline. But as I said, I think it is a matter of discussion because this is as well in our plans.
Yeah, okay, interesting. And maybe somebody can bring their own pipeline, or I don't know. We've tried to answer the questions as far as they're in the chat, but it doesn't end here. The webinar may end. You can look this back. It is recorded. There is the link to the web page and the flyer of TNO with a lot of information about the Switch Field Lab facility. And of course, if you download or if you contact us to request the project ID form, there's even more information in there as well. So if you're interested, please follow that route. If you would have any other questions, feel free, of course, to contact us as well here at TKI or at TNO. So I would really like to thank Glenn and Nirache for preparing all this and also making the Switch Field Lab available for research that could potentially be sponsored by the TKI PPP allowance. I would like to thank the audience for participating in the webinar. And again, feel free to contact us with any further questions. Thank you very much.
Thank you very much as well.
Thank you. Goodbye all.